Okay, here we go with some conic sections. Right now you can see the two conic sections right here, a circle and an ellipse. And then if I zoom out a little bit, you can see the other two, a parabola and a hyperbola. So this word conic, of course, means cone, and we have cones right here. And when cones are sort of intersected in the right way, you get one of these four different sections, these cross sections. So what happens is a plane comes through and cuts through the cone. And depending on the angle of that plane, will give you a specific type of cross section. For example, if the flat surface is sort of parallel with the top or the bottom, that gives you a perfect circle right in here. If the plane is tilted just a little bit, it gives you an ellipse. Now an ellipse is not too much more than an oval. If the plane is parallel with one of the sides of the cone, the slanted edge of the cone, then that gives you a parabola. So an ellipse looks like this. A circle, you would of course know, looks like this. A parabola looks like this, something like that anyway. And when the plane cuts through and it is parallel with the vertical axis of the two cones, that gives you what we call a hyperbola, which is a sort of a double figure here where it looks like this. These are the four conic sections. Now, I am not technologically advanced to create like nice animations with this, but what I am going to do for you is put a link in the description of this video of what I think is the best animation out there to help you see what these sections are all about. So check that out. It's only about a minute long and it's really great. So our job, of course, is to sort of examine circles, ellipses, parabolas, and hyperbolas and look at their different properties and equations and all sorts of great stuff. We're going to graph them, we're going to write equations of them based on graphs, and talk all about their points, their foci, and all that stuff. We're going to use a lot of cool terminology and new words for you, new definitions. So in the previous couple videos was sort of an intro to circles. I'm not going to really focus too much on circles because you probably, from your geometry classes, have a really good idea of what circles are all about. And in fact, I have many videos on circles. The previous two in this playlist, of course, plus a few of my geometry playlists you can check out. So I'm going to jump right into a study of parabolas. So let me zoom back in here and we'll get started. So a parabola, by definition, is the set of all points in a plane that are the same distance from a fixed line, which is the directrix, that's down here, and a fixed point, which is the focus, that's up here. So the focus is going to be the point that's inside of our curve, right? If we think of parabolas as being curved, the focus is inside of that. The directrix is on the other side of that. I think of the directrix as sort of like a backboard to the parabola. In other words, the parabola is going to always face away from the directrix. And what's going to happen is, in between the focus and the directrix, there's going to be a really important point called the vertex. Now in your Algebra 2 class, and in fact probably in your Algebra 1 class to some extent, you looked a lot. You worked with parabolas a lot, and we noticed that parabolas can face up, they can face down, they can be really wide or really skinny, depending on the lead term, if it's positive or negative, if it's a fraction, or if it's a really big number. Alright, but this whole idea of equidistant, this same distance between a focus and a directrix, means that if we go up here and say that this distance from the focus to this point x comma y, let's say that is 12 inches. And that means this distance is 12 inches as well. These are the constraints of a parabola. Every parabola has that property to it. This might be, I don't know, 8, and this is 8. Alright, and you can see that the shortest distance from this point to the directrix is at a right angle. So we're going to look at stuff like that. We're also going to look at parabolas that are not even functions, they're facing sort of sideways, and that's going to change the whole equation of the parabola. So here we go. All right, most of your experience with parabolas has probably been looking at, f of x is equal to x squared. In other words, y is equal to x squared. And that graphs like this. Of course, if you wanted to make a t-chart out of those values, it's pretty simple. 1 and 1. When the x value is 2, when x is 2, y is 2 squared. When x is 3, y is 3 squared. And same thing in the other direction. If y is negative 3, if x is negative 3, the y value is positive 9 as well. But there's a little bit more to it when you start getting into the study of parabolas as they relate to conics, because there's changes in the vertex. And this is the standard form of a parabola right here. You can see that it's kind of complicated, but we're going to go through it step by step and really try to make some sense of it. But when we talk about the vertical axis, all right, that means that the parabola is opening up or it's opening down. All right, because the vertical axis looks like that. But sometimes, as I said, the parabola can be sideways. And that is when the axis is horizontal. So it would look like this. Alright, so we're going to look at these two different forms. That's when the vertex is anywhere, h comma k. And we'll also sort of step back and make it a little easier when the vertex is at the center of our graph, the origin, if you will. Then they take on these much simpler forms because the h and the k sort of disappear. Alright, so we're going to really take a look at what it means to, what this value p means, and what it means to be a directrix, how to find the directrix, and we'll go from there. Let's see what we can do. So this is not the standard form, but what we call the vertex form of a parabola. This is what we're probably more used to seeing from our Algebra 2 classes. We have y equals some number. A lot of times that number is 1, but it doesn't have to be. It could be a fraction, it could be positive, negative, could be a big number. And then we have x minus h, and your Algebra 2 teacher probably taught you that this is, the h value is your x coordinate in your vertex. And then we have plus k, which is your y coordinate in your vertex. And if a is greater than 0, then the parabola opens up. If a is less than 0, the parabola opens down. Alright, so this is when the parabola has a vertical axis. It's up and down. So in example 1, find the vertex of this parabola. Alright, so what I like to do here is I like to remind myself that I need to figure out which way it opens and then what the vertex is. So if my form starts with a y and has the x squared term, then that means it's going to be opening either up or down. And if that lead term, that A term, is negative, then this one's going to open down. And the vertex of this is going to be, this is right here, the 4 is going to be it's negative, of course we want to always use the opposite. That's going to be the x coordinate of our vertex, and this we're going to keep positive. So my vertex is negative 4, 1, 2, 3, 4, positive 5. So it's up here. That's our vertex, and this thing's opening down. That's not a very good picture. It's not much better, but I think you get the point. Alright, this thing opens down and it has a vertex at negative 4, 5. That's like the basic example. Right, that's the first thing you want to do, is think about which way it opens and where your vertex is. Then we're going to really from there get into this idea of the directrix. Let me zoom in on this a little bit. We're going to get an idea of where how to find the focus, which would be like right here, and then how to find the directrix, which is going to be equidistant from that vertex. It's going to be equidistant, up here somewhere. So that's going to be our directrix. And we're going to get information on all this stuff and really make connections between how this distance is the same as this distance right here. And that's going to be called our P value. Number 2. Alright, we have a lot of stuff to do here. In this case, we want to actually find the focus and the directrix. So again, this is going to be opening either up or down. Based on the lead term, I know that it's going to be opening up. It's a fraction, so it's going to be sort of really wide opening up. The vertex of this thing, you notice that there aren't any H or K values. In fact, there are no parentheses at all. So my vertex is right at the origin. And the first thing we want to do is, when we see this, we want to get into the habit of using this form right here. Alright, this is the form that will help us get the focus and directrix. That P value is what we're looking for. And there are a couple different ways to do this, depending. Your teacher might present this to you differently, but when I present it to my students, I use this format. Some people replace 4P with just a different coefficient or a different variable, but your job is, in this case, to get the x squared term by itself. Alright, so what we're going to do is try to isolate that x squared. So let me rewrite the original. And I'm going to try to isolate the x squared term. Let me scroll down a little bit. So to isolate that x squared term, because again our goal is to get it into this format where x squared is by itself, and that from there we can find the P value. All I want to do, of course, this goes back to algebra 1 or pre-algebra, is multiply both sides by the reciprocal of this fraction. And what that'll do, of course, is cancel the 2's, cancel the 5's, leaving you with 5 over 2y is equal to x squared. Alright, and that mimics this form exactly. And when it does, all you want to do is, here, let me do this. Let me write this down. X squared is equal to 4py. And what we just got, x squared is equal to 5 over 2y. And the reason I'm doing that is because now you can probably see that 4p is the number in front of y. It's the coefficient of y. So the green things simply just get set equal to each other. Alright, and now what we're doing here is our next step, which is finding the P value. So 4p, 4 times some number p is equal to 5 over 2. Well, divide both sides by 4. So 5 over 2 divided by 4. So I'm going to do that and change the division to multiplication by 1/4. So the p-value is equal to 5/8. And that's really important. That is our p-value, and that's going to help us find the focus and the directrix. So when you have it there, now it's probably a good time to go to your graph. As I mentioned, your general shape is going to be opening up and rather wide, and the vertex is at 0, 0. So let's go to our graph, and I'm going to put in my vertex at 0, 0. That's my vertex, and my p-value is 5/8. Now what that does for us is tells us, since we know the graph is opening up, that tells us that our focus is going to be up here, and our directrix, which is our sort of our imaginary line boundary, is down below. The p-value tells you exactly how far to go up from your vertex and down from your vertex. The focus in this case is going to be up, and your directrix is going to be down. So from that point 0, 0, that vertex, we're going to go up 5/8 units, which is a little bit more than 1/2. So I'm going to put my focus, I'll put it in red since this is red. So I'm going to put my focus right there, label it point F, and I need coordinates of that. Well, it's 0, 5/8. The directrix goes in the opposite direction. I'll put it in bright green. It goes P in the negative direction. So there's going to be a horizontal, and we usually draw it dotted line down here. That's called my directrix, and that would be given by the equation y equals -5/8. And that again acts as sort of a boundary for our graph, and it might be a little bit wider, something like this. And again, the whole idea behind this is that if you pick any point on that curve, on that parabola, this distance from the focus to that point is the same as this distance from the directrix to that point at a 90-degree angle. So I didn't draw it particularly well, but hopefully you get the idea. Again, if this is, you know, some value C, then this is some value C. So there you go. That's how to find the focus and directrix. And I think I'll end this video there. In the next, this will be part 1 of our parabola video, but in part 2 and maybe even part 3, I'm going to get into a few more examples like this. And of course, we want to begin to examine what happens, how to work with parabolas that are sort of sideways. So I will see you in the next